Hello, everyone, and welcome to AI with Sohini, where we talk about anything and everything in the world of artificial intelligence. This is the second part to the introduction course to generative AI that I'm creating, and there will be one more that we follow up in order to bring all the ideas together in and around the world of generative AI. I wanted to mention in the next episode, I am going to be talking about the latest deployment of Gemini by the company Google and how it is actually making a lot of buzz in and around the domain of large language models. So please stay tuned for that. And in the last video, which I will be linking up here, I talked about the introduction to generative AI. What is large language models, how they have evolved, and what is the journey that is needed in order to build large language model-based products. In today's video, I am actually going to go deeper into the idea of building a prototype. So if you have access to large language models, it can be through your Bing chat, it can be through your OpenAI license. If you have access to any kind of large language model, you can start building your own customized products. And what are some of the considerations you need to keep so that your product is successful? So I will show you a typical architecture that you can follow in order to build your own custom systems in and around large language models. I will also point you to some of the GitHub where you can start coding yourself if you are so interested to in building a whole career around generative AI. So if this is of interest to you, please give this video a thumbs up and subscribe to this channel. So today we start with understanding what are the different components that are needed in order to design a prototype of a solution using large language models. So this is an example of a typical LLM use case system design. So in this case, we are starting with, let's say the user wants to ask a financial portfolio based question. So the user has their own stocks, invested, and they really want to know how their stocks are doing. So in this case, the user will ask the question, and a prompt is what gets generated, pulling from the data source, which is the user's own stocks and their details. So the information gets pulled into the prompt, and then it gets sent to a foundational model. Now, foundational models are the typical large language models that we know and we hear about, like GPT-3, OpenAI's GPT-4. There is Llama, there is Google's Palm. So whatever you may want to use, that is called your foundational model. And then there is a response along with which you give a feedback, thumbs up or thumbs down. You can also regenerate the response if you don't like it. And this process keeps on going. However, the novelty, whenever you are trying to customize this whole architecture for your own solution, these are the components that you will need to create. First of all, there needs to be an intention classification. So what typically happens is every single question has its own way of getting an answer. Like a what question is very different from a why question or a how question, which needs more in-depth analysis. That's the reason why we typically use any kind of classification process in order to classify what is really the user asking for. Is it a what question versus a why question or a how question? And what database is it coming from? Next, there is a way in which the data is divided into chunks and it is collaborated along with instructions. So there is the question along with the data chunks, which is, everything is put together in order to generate a customized prompt. And this is the prompt which then goes to hits the large language model. It can be GPT-3, it can be, as I mentioned, Llama, or it can be Palm 2. And finally, there is also a need to score the responses. Now, there is this concept which is called hallucinations in and around large language model, which is the large language models can very confidently give you the wrong answer. So there is always a need for you to figure out, is there any errors in the responses or not? And there are a lot of ways that are up and coming in order to do that. I'm going to link a few blogs and articles from my team in the description box below. So let's see what it means to really make prompts with this infrastructure, which is called LangChain. So LangChain was again evolved and it was distributed by OpenAI's creators themselves. And as the name suggests, it takes language models and it chains data entities in order to get you to the optimal result. So there are different components that you really need to build in order to have a very full and concise prompt. Now let's see what the different components of a prompt are. The first component in a prompt is called the header, where you typically introduce the persona and the steps that you want the whole question answering system or the chatbot to follow. Personas can be like a bubbly personality where you want to crack jokes, or you just say you're a virtual assistant, you should just give me the answers and that's it. The next component is called a preamble. Now, what typically happens is every domain is extremely customized, which means there is always a defined set of keywords that are very specific to that domain itself. For instance, if we are working in the finance domain, things like SAP is the name of a company, but if you just say SAP without defining what that is, the large language model will assume it is TreeSAP. So that's the reason why whenever any single domain has very specific keywords, they need to be defined in this section called the preamble. Next, there is the content, and this is where the most relevant data chunks are identified and chained together in order to give the best possible response from the large language model. And then comes the instructions. These are the instructions that are different corresponding to the different intentions. So if it's a what question, the instructions that you need to give to the large language model is different from the instructions that's needed if it's a why question. And finally, this is called the zero shot or few shot mechanism of working with large language models, where you give it a sample question and a sample answer so the large language model knows how you want your response formatted. So these are all of the different components that need to be put together in order to generate a perfect prompt. Now let's take a look at what an ideal question answering system where the source is purely data tables. Just as I mentioned, let's say you're trying to build a chatbot around your own financial portfolio. What are the investments? How are they doing? If you want to generate your own customized financial chatbot, then all your data should come in tables. So if you want the input to be tables, but the output to be language, then that is a data question answering system that we're talking about. So let's say the human query in this case is what percentage of financial stocks have a steady growth this week in the New York Stock Exchange? If you see, there are multiple keywords that keep popping up at us in this case. So that is the first thing that we need to figure out. What are the keywords and what is the intention of the question? In this case, you see the intention is a what question. It's not asking why or how. It is a very simple what question. That means it is asking you to just fetch the data, and there has to be a few steps in order to fetch the correct data. Now, next we do a keyword search. So in this case, the keywords are financial stocks, steady growth. That's what you want to extract. This week, again, that gives you the time period, and the location is New York Stock Exchange. So that's the different keywords that the large language model is able to extract from the question itself. Now, let me show you the steps, which is called grounding, in order to generate a perfect prompt template, which requires minimal coding and only very clear English or your typical language-based instructions in order to generate this chatbot for you. So this is how you need to first create a few functions in the backend in order to fetch the right data. As I mentioned, a what question is a simple data fetcher, but you need to fetch the right data. So in this case, these are the few functions that you need to already have constructed. First of all, there is a function stock name lookup. So in this case, I mentioned financial stocks. So out of all the stocks in New York Stock Exchange, I first need to filter out all of the financial stocks. Then I look at the geolocation. So the geolocation in this case is New York Stock Exchange. Then I need to find a definition for a stable stock. So how do you find that a particular stock is stable or not? So ideally, you will have to iterate through all of the financial stocks and see what is the average, the mean, and the standard deviation. And if the standard deviation is relatively low, then you can say, okay, this is a stable stock. And then there is a stable stock per geo ID. So in this case, it's not just all of the stable stocks, but the stable stocks for financial stocks in New York Stock Exchange. And then if you see, the question actually says what percentage. That means it is a fraction. You also need the total number of stocks that are there in New York Stock Exchange in the financial aspect. So that's the reason why you need the total number of stocks as well. And finally, a small function which will divide the numerator from the denominator in order to give you the percentage. This is followed by very simple instructions in which you tell the large language model that try to answer this particular question using the functions that you have at hand. Now let's see what will the large language model now do. Now the large language model will, first of all, it will start identifying the stocks in the finance domain. Next, it is going to find out the stocks that are there in New York Stock Exchange. And then, like I mentioned, it's going to run that function which will identify the stable financial stocks. And then another function that identifies all of the financial stocks in New York Stock Exchange. And the last one is just going to do a numerator divide by denominator in order to give you the percentage. And finally, the response is formatted in the format the user has asked. So if you want line, if you just want the number, that's how the response is going to get returned back to you based off of the persona that you have already constructed in the prompts preamble. Now let's try to understand how the LangChain process typically works on large documents. So let's say that you have a large document. In this case, I'm just showing you an example of a Word document that has multiple question and answers. So it's a typical text essentially. So there are two, essentially, you can see that there are two very different topics that we are talking about here. In the first one, it's asking, how do you organize your email? And the second one is, how do you shrink the size of your email? So in the back end, what's going to happen? So let's say you have all your documents. So all your documents that you have in your Google Drive. The first step that you have to do, it's an offline process, is you have to divide all of this text into data chunks. So let's say the first one, and again, in this case, the size of the data chunk is limited by character size. It can be the token limitations. So tokens are just the way the system understands words. Ideally, tokens represent syllables. So typically a single word can be 3 to 4 tokens. But that's what the system understands, to take the whole text and divide it into different data chunks. So ideally, in this case, if you go by a word count or a character count, you will say the first question becomes chunk 1 and the second one becomes chunk 2. So this is again an offline process. The next thing that needs to happen is this chunk needs to get embedded into computer understandable format. Now, computer understandable format is always zeros and ones. It's always digits. A system does not understand human language. That's the reason why it needs to be embedded, and there are multiple embedding algorithms out there. There is ADA, there is Babbage, there is BERT, there is Gecko. There are multiple data embedding algorithms that can be used to convert your standard data chunks into machine understandable vectors. And understand the size of all the vectors will always be same. So if there is a chunk 1 has 1,000 characters versus chunk 2 has 500 characters, the size of the final vector will always remain the same. Let's say 1,500 in this case. So chunk 1 gets embedded and so does chunk 2. So every single text chunk or paragraph gets converted into system understandable format. Now, let's say that a user asks a question, how to summarize an Outlook file. So you already have a Google Doc that you have already pre-prepared with this data chunk and everything. Now, if you start asking a question, how do I summarize an Outlook file? What will happen as a first step is this question will first get embedded. So the same technology or the same algorithm that converted the data chunk from paragraph to the computer understandable format, the vector, the same algorithm is used to convert the question into its embedded format. So again, 1,500 dimensions. And then there is a chunk ranking or a similarity finding search. So what happens is based off of the size of the vector, it tries to find which embedded chunk is most similar to the question. So it's a similarity based search. And again, it's a very fast process. Based off of the similarity, just goes through all of the data chunks and identifies all of the ones that are decently similar. So it computes a value between 0 and 1, and the higher the number means the data chunk is more similar. So in this case, if you see the second chunk, which is how do you shrink the size of a mail, that is actually more similar to the question than the first chunk. So that's why the second chunk gets passed along with introductions, the specific definitions, as I mentioned, the persona, and a typical question and answer in order to typically answer this question, how to summarize an Outlook file. So this all process is a part of LangChain, where you first have to pre-process or pre-prepare all of your data, break it down into chunks, and then embed them so that every incoming question, it will just find the right data chunks, agglomerate them, and those chunks are then passed to your large language model to get a response. So that is why LangChain becomes an extremely powerful system architecture that pre-process the documents so that you can have large databases that can be easily queryable. This process is also known as retrieval augmented generation or RAG, in which the right data is always passed with the right question to the large language model. Finally, I wanted to talk to you about how important it is to take the responses of every large language model and to evaluate it. As I mentioned sometime earlier, that there is this concept called hallucination, which is the false responses. So a lot of times it could happen that you are asking about a fact, and that fact actually happened with some other stock, not your stock. In the New York Stock Exchange example, but the large language model just got that information and it just hid it. It says this is your stock and this is how it's performing. So that is called a false response or a fake response or a hallucination. So what we have done typically in our work is we have generated 4 different metrics in order to evaluate every single large language model response. So think of it as an English teacher and a math teacher sitting on top of the large language model response, trying to evaluate how good or how bad its response is. The first English teacher, it typically takes a look at the question. It takes a look at the prompt and it takes a look at the answer. If I asked you about New York Stock Exchange, did you give me the response of New York Stock Exchange, or did you give me the response of some other stock exchange? So that's what the English teacher is looking for: context. Did you follow the same context that I asked you about? The numerical accuracy is where the math teacher takes a look at the large language model and figures out all of the numbers in the response. Were they in the prompt to begin with or not? So typically large language models, and you will see in the examples that I show next as well, large language models are not good at doing math because they have not been trained on math. They have been trained on language. So that's the reason why numerical accuracy sometimes can be extremely poor. So that's why in these cases, we want to make sure is whenever you pass the data chunks have the numerically accurate numbers. And that's the reason why the math teacher is going to see that did every number in the response correspond to what was passed through it in the prompt itself or not. So we take away the burden of doing any math from the response completely. And then finally, there's this concept of uniqueness. So what we see a lot of times is if the models are smaller. So if you're using a lot of text on smaller models, like the iLlama or the 6 billion versions, the models have a tendency of regurgitating. So if you have a few sentences in your text, it will start giving you the same sentences back. So that's why it is always necessary to check if the responses were unique enough or not. And finally, sensibility. Now, ideally, large language model responses are sensible because they are not human. They are automatically generated. However, sensibility takes a hit whenever you're working around numbers. So you can have sentences that says your stock prices increased by -2%, which makes no sense. Or it can say your stock prices went down by 2%. So again, that does not make sense. So specifically, whenever you have numbers and language involved, it is always important to see if there is a word increase, then you should have a positive number associated with it. If it's a decrease, then you should have a negative number associated with it. So that's the sensibility check. Ideally, every single response will have a binary mechanism of scoring each and every one of them. And if overall you get all 1, then ideally your score is a high confidence. So ideally what's going to happen, a response is going to come up with a high confidence if all these metrics are 1. If any one of these metrics are 0, we call it medium confident. And if multiple of these metrics are 0, we say it's a low confidence. That means we're not sure that there is a high probability that a hallucination has happened. So typically what we do in order to monitor for batches of redeployments, we have a batch of questions that we run every single week and check if the overall average response characterizations are high or not. Like in this case, typically a quality score, let's say for a batch of 300,000 questions comes back with 92%, 91% for each and every one of the metric, then you know that the current deployment was successful and the hallucination is minimum. So always understand whenever even generating a prototype, it is very important to make sure you monitor the hallucinations because hallucinations are a reality with regards to large language models. Now that we have covered how to design a typical prototype, I wanted to provide some materials for any of the data scientists who are interested in building their own custom, chatbots. So the first question I typically get is, I want to get into natural language processing, which is the precursor to large language models. How do I do so? So typically, Hugging Face is the best resource in order to do that. So I'm going to be linking this in the description box below. So first of all, if you see that there are different summaries of the tasks, how do you pre-process data? So if you have language formatted data, how would you go about pre-processing the data? Fine-tuning a pre-trained model. Now, this is typically getting into the area of machine learning where you have new data and you really want to pre-train an existing, you have an existing model, you want to fine-tune it. And then there is this concept around tokenization. So if you really are a machine learning engineer and you want to become a natural language processing engineer, you really need to understand tokenization. Tokenization is converting natural language into machine understandable format. So each and every one of them, you can actually open it in Colab, you can clone it, and just run them one by one. And this should help you understand what tokenization is and how it should really be working. So in this case, it shows you a very simple example of word tokenizer. Now, one thing I do want to mention is getting into a field of natural language processing. NLP is the combination of natural language understanding, or NLU, and natural language generation, or NLG. So these basic concepts around tokenization, understanding the word to vector, how the language gets converted into machine translatable form is super important, and then becomes this idea of generating the text, where you can generate new language based off of maybe an existing guideline, or if you have written 2 lines, you wanted to generate 2 more lines. There are ways in order to do that.